Determination of magnetic field strength or magnitude of magnetic field. Determination of magnitude of magnetic field. B. Using a magnetic needle. Let us assume or let us consider a small compass needle of magnetic moment M and moment of inertia capital I. Moment of inertia, recall from your class 11 chapter, moment of inertia is placed in a uniform magnetic field. Let us say here is an uniform magnetic field of strength B and we place a small magnetic needle. This is a magnetic needle. Let us say this is North Pole and this is South Pole. And this magnetic needle has magnetic dipole moment capital M. Capital M is the magnetic moment of the needle and I is the moment of inertia. Moment of inertia of the magnetic needle. Now this needle will experience a torque, right? Will experience a torque which makes it oscillate. And the torque acting on the needle is, already we have deduced that mb sin theta. If at a particular moment m, that is magnetic moment, makes an angle theta with the external magnetic field, right? But we know tau is equal to I into alpha, where I is the moment of inertia and alpha is the angular acceleration, and that can be written as I into d2 theta dt square, where theta is the angle which is called the angular displacement, Now, for if this is an equilibrium position, then you can say from the laws of motion you can write this as equal to that. Clear? We can write this as I d2 theta dt square is equal to minus mb sin theta. Why this is minus? Because this negative sign indicates that restoring torque acts opposite to the direction of the displacement of the magnetic dipole or magnetic needle. See here, this, if we displace this, if is the magnetic dipole or magnetic needle makes an angle this theta, then the force or torque acting on this magnetic needle try to rotate in this direction. This is the direction of the torque, but displacement is from in this direction. That's why the direction of the displacement, angular displacement, and torque acting on the magnetic needle is in opposite direction. That's why we put here a negative sign. Or from here we can write I d2 theta dt square plus mb sin theta is equal to 0, or we may write d2 theta dt square plus mb by I sin theta is equal to 0. Now if we assume that theta is very small, then this sin theta can be replaced. Theta is very small, then sin theta can be replaced by theta, and from that you can write d2 theta dt square plus mb by I into is equal to 0, or this can be written as d2 theta dt square plus omega square theta is equal to 0. You can, if we write this as omega square, then this can be written as this, and which is an equation of SHM, simple harmonic motion. Recall your previous knowledge of SHM, simple harmonic motion, right? Then we can write omega square is equal to mb by I, or omega equals root over mb by I, which is called the angular frequency. In our starting discussion, we have said that since compass needle experiences a torque, then it try to, or it want to oscillate, right? And that angular frequency of that oscillation is this. Or from here you can write also that omega equals to 2 pi by t is equal to this, or t is equal to twice pi root over I by mb. T is equal to twice pi root over I by mb. This t is the time period of oscillation of the magnetic compass needle, time period of oscillation of the magnetic compass needle in the uniform magnetic field, right? And from here you can also write, from here or here, whatever, you can also write that t square is equal to 4 pi square I by mb. Now b can be written as, see here, b can be written as, just bring b here, then this t square going to the denominator of this term, or from here you can write b is equal to 4 pi square I by t square into m. 4 pi square I by t square into m. From here you can measure the magnetic field. From here you can measure the magnetic field. This. Clear? Just we know what is I. I is the moment of inertia of the magnetic needle. M is the magnetic moment of the magnetic needle. Just you have to measure the time period. If I can measure time period, I can get the magnetic field. Clear? Strength of the magnetic field. In our previous discussion, we have said that you cannot measure magnetic field strength by putting a unit or bringing a unit north pole. That is not possible, because in reality there is no monopole, magnetic monopole. That's why you cannot measure in that way the magnetic field. This is one way to measure the magnetic field strength.